Assalamu alaikum, my dear students. How are you? Hope you are fine by the grace of Almighty Allah. Welcome to NIBS Home School. This is Shahjadi Akter, Assistant Teacher of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 9 students. My dear students, let's start our class. Our today's topic, chapter 2, reading done, page number from 38 to 43. Our today's lecture number 7 and HW number 6. My dear students, let's start our class. Chapter 2, motion. Today we will discuss at first about distance and displacement. Okay, my dear students, listen. We are quite familiar with the word distance, but we do not use the word displacement in our daily life. We want to understand the relation between the two words distance and displacement with the help of an example. A curved path shown in this figure. See this figure. There is a curved path and the distance traveled with respect to the point A is denoted here. Point A is denoted by the number of 1, 2 and 3, okay, in kilometer. Let us consider you are in point A. You are at point A and now you have reached about point B by 4 kilometer, okay. This one is 4 kilometer where by riding a bicycle along this curved path. And we can say the distance between point A and point B, point A and point B is 4 kilometer, okay. The distance between point A and B is 4 kilometer. Distance is a scalar quantity, my dear students. This one is important for you. This is important for MCQ. Distance is a scalar quantity. So to express the distance between points A and B, we need not mention any direction, okay. So we determine the distance of the point B along this path with respect point A. Now if we desire, we can determine the displacement of point B. If we can determine the displacement of B with respect to point A by displacement, the position of point B is respected to the point A is named, okay. And in this figure, the displacement is shown by a straight line from point A to point B with an arrowhead, okay. And in this figure, the magnitude of the displacement is 3 kilometer. The magnitude of displacement is 3 kilometer. And the direction of the arrow is in direction of the displacement. Okay, therefore displacement is a vector quantity, my dear students. This line is important. Displacement is, this is important for MCQ, displacement is a vector quantity. It has both magnitude and direction, okay. Why displacement is vector quantity? Because it has both magnitude and direction. And if going 2 kilometers or more by cycle, you cross 6 kilometers path total and reach point C, and then your displacement will be the straight line AC, okay, AC with an arrow and whose magnitude is 1.5 kilometer, and the direction of the arrow is along your displacement. Okay, my dear students, now this is also very important for you. The difference between the initial and the final position of is the displacement. What is displacement? Displacement is the difference between the initial and final position, okay. And now starting from point A, and the distance towards point B is 4 kilometer. Starting point A and point B, towards point B is the difference between 4 kilometer. Between these 2 points is 4 kilometer along the curved path, and similarly the distance between point B and point A is 4 kilometer. Okay, that is both are equal. The displacement and distance between point A and B is 4 kilometer, but notice that the displacement from point A to B and the displacement from B to A are not equal, okay. From A to B and B to A are not equal, and that is the vector AB equal minus vector BA, okay. And distance or displacement both have the dimension of length, okay. Both have the dimension of length. Distance and displacement both have the dimension of length. The displacement, the dimension of displacement is L vector, okay, L, and the distance also L. Dimension of distance also L. Displacement is vector quantity and the distance is scalar quantity. Okay, now come to speed and velocity. Now we will know about what is speed and what is velocity. My dear students, this one is very important question answer also. What is called speed? Speed is the rate of change of distance with respect to time. Okay, the rate of change of distance with respect to time is called speed, and here given example. And therefore, if you have curved 100 meter distance in 20 seconds, your speed will be V. We denote the speed in V. V equal distance divided by time. Distance divided by time. Okay, here given distance is 100 meter and time is 20 second. That means distance is 5 meter per second. Okay, my dear students, this one is also very important. The dimension of speed is V equal L per T. Okay, the dimension of distance is L and time is T. That means L per T. This is the dimension of speed. Okay, now come to velocity. What is velocity? The rate of change of displacement with respect to time is called velocity. My dear students, memorize properly these two definitions. Okay, the rate of change of displacement with respect to time is called velocity, and we denote the velocity also V. And here is example. If the change of your position along a certain direction in 50 meters in 20 seconds, then magnitude of your velocity will be V equal displacement divided by velocity, means displacement divided by time. Displacement divided by time. That means here given displacement is 50 meter and time is 20 seconds. That means velocity will be 2.5 meter per second. My dear students, we have already learned the dimension of speed and dimension of velocity is same, and the unit of speed and unit of velocity also same. It will be meter per second. Okay. Now velocity is a vector quantity and the dimension of velocity is also L per T. We have learned it. The dimension of speed and velocity is same. My dear students, now come to here. Here one thing has to be noticed. If we consider only linear motion, then there is no difference between velocity and speed, and the magnitude of velocity is the speed. In this book we shall consider only the linear motion. My dear students, in this book we shall consider only the linear motion, so we will not find any difference between speed and velocity. So to understand the internal relationship between speed and velocity, some examples beyond linear motion is discussed. Okay. To explain distance and displacement, we considered a curved path in figure 2. In figure 2, this figure, and showed a different, this is a curve and showed different position in that path. Okay. To have an understanding about speed and velocity, we can consider the same example, but now we have to tell how much time you have taken for going from one position to another, and suppose you have taken 20 minutes. Okay, 20 minutes for coming this position from position A to B by cycle. From A to B 20 minutes taken, and then average speed. What will be the average speed? Now my dear student, this is the formula of average speed. Average speed is distance traveled divided by time. Okay, therefore speed V equal, here given distance travel, here given 4 kilometer. That means 4 will convert this kilometer in meter. That means multiply 1 with 1000 meter. 4000 meter, and time is 20 minutes. Time is 20 minutes. That means 20 into 60 second. We will convert this to 60 second. That means 4 into 1000 meter divided by 20 into 60. that it will be 3.33 meter per second. My dear students, this is the unit of speed. Okay. Notice that we have used the word average speed instead of the word speed, because while you are riding a bicycle, sometimes you rode fast and sometimes you rode slow. So we cannot talk about the instantaneous speed, rather we can talk about the average speed in the time interval. Okay. Now come to velocity. Okay. The velocity, the average velocity will be is the formula of average velocity is displacement divided by time, and here given displacement is 3. Displacement is here given displacement is 3 kilometer. That means we have to convert this kilometer into meter. Okay, multiply with 1000 meter, that means 3000 meter, and time is 20 minutes. And we will convert this minute into second, that means 60 seconds. Okay, that means the average velocity will come 2.5 meter per second. Okay, my dear students, in this example you have noticed that the value of average velocity is less than the value of average velocity is less than the value of average speed. That means here given average speed is 3.33 meter per second and average velocity is 2.5 meter per second. Okay, if the path is straight rather than curved, then the magnitude of the average velocity will be equal to the magnitude of the average speed. Okay, and come to next page. In our example, if you rode your cycle always at the same speed, and then we say your speed is uniform speed. Okay, uniform means same speed. We when anything moves with uniform speed, then its instantaneous speed and average speed will be the same. And now come to this example. Here given example, if the stone is suddenly released, it will move with uniform velocity and with uniform speed. The answer will be, if the stone is released suddenly, it will be move straight with uniform velocity and uniform speed, and it will continue to move with uniform velocity and uniform speed if there is no air friction, air or gravitational force, etc. Okay, my dear students, now come to acceleration and deceleration or retardation. What is acceleration? We'll know now what is acceleration and what is deceleration or retardation. My dear students, acceleration means when an object moves with uniform velocity, it has no acceleration. Okay, when an object moves with uniform velocity, that means same velocity, it has no acceleration, and if there is a change of velocity, then there is an acceleration. Okay, and we can say the rate of change of velocity with time is called acceleration. Okay, memorize properly this definition. What is acceleration? The rate of change of velocity with time is called acceleration. Since velocity has both magnitude and direction, the change of velocity can occurs in two ways. In our previous example, when you rode bicycle in a curved path, then change of velocity occurred at every turn and you are accelerated. Though you have you traveled the whole path with uniform speed, acceleration took place due to the change of direction only. And if you tied a stone with a string in the previous example and rotate it over your head with uniform speed, then the rotating stone would change its direction and of motion continuously. Okay, that is change of velocity will occur and acceleration will take place. And if your motion is linear, then there is no scope of changing direction. That means the acceleration may occur only for the change of magnitude of the velocities. And when the magnitude of the velocity increase, then we can say acceleration is taking place along the direction of the velocity, and if the velocity decrease, then we can say negative acceleration or deceleration is taking place. Okay, my dear student, that means deceleration means the negative acceleration. Okay, deceleration means the negative acceleration, and we can determine the acceleration of an object moving along a straight line. My dear students, see this figure. In figure 2.6, the change of velocity of an object with time is shown. Here time, given time, and here given velocity, and identify where there is acceleration and where is absent. Okay, in point A there is point A, B, C and D, and there is acceleration at point A. Okay, there is acceleration at point A, and V there is no acceleration because there is no acceleration, and because their velocity is same, and at point C there is acceleration, and D there is negative acceleration, that means deceleration. Okay, my dear students, now what is acceleration? Acceleration is the rate of change of increase of velocity with time, and if the acceleration is uniform, it will not change with time, and then we can write acceleration equal, you have to memorize this one, acceleration equal final velocity minus initial velocity divided by time. This is the formula. Okay, acceleration means final velocity minus initial velocity divided by time, and if the initial velocity of an object is u, and the after time t the velocity becomes b, then the acceleration will be a equal v minus u divided by t. And this is the formula of acceleration, a equal v minus u divided by t. My dear students, the dimension of acceleration you have to memorize also. Dimension of acceleration is L t inverse 2. Okay, L t inverse 2, and the unit of acceleration is meter per second square. And when the acceleration a is known, and if the initial velocity is u, then the after time t it is very easy to find the final velocity. Okay, that means v equal u plus at. From here we can write v minus u equal at, or v equal u plus at. Okay, this is the equation of motion, v equal u plus at. And when when the object starts motion is from rest, then u equals 0, we can consider equal 0, then v equal to u plus at. My dear students, hope you have understood our today's topic. I will give you give SW now. Your SW will be today's SW number 6, and SW will be all definitions from this lesson. What is distance, displacement, what is speed, velocity, what is acceleration and deceleration. Okay, this will be your SW, and submit your SW on Saturday. Okay, submit it on Saturday. My dear students, hope you have understood our today's topic properly. Memorize properly these all definitions, and keep practicing at home. See you again in the next class. Allah Hafiz.